For arbitrary transformations, it can be difficult to determine whether they're one-to-one and or onto. For linear transformations, it's straightforward. In this video, we present theorems on the topic. First, let's consider the question of onto. Let T be a linear transformation from Rn to Rm, and the question is, for every vector B in Rm, is there a vector C in Rn such that T of C equals B? Well, we know that if T is linear, T of X can be written as A times X. So let's investigate this question in terms of this matrix A. What we're asking is, does AX equals B always have a solution? And we already have a theorem to answer this. AX equals B always has a solution if and only if every row of A contains a pivot position. So we can state our theorem. A linear transformation from Rn to Rm is onto if and only if the standard matrix of the linear transformation has a pivot position in each row. We'll now address the question of one-to-one, and it will again come down to investigating the standard matrix. So, given a linear transformation T, does T of W equaling T of Y imply that W equals Y. Again, we'll recast this in terms of the standard matrix of the linear transformation. Let A be that matrix. That is, let T of X equal AX. And what we're asking, reframed in terms of this, is if AW equals AY, does this imply that W equals Y? Be careful, you cannot cancel these A's. We don't have a division operation that would let you cancel. So the answer isn't necessarily obvious. Well, again, rephrasing this question a little. If these things are both equal to the same vector, call it B, we're asking, does AX equals B have only one solution? That is, if W is a solution and Y is a solution, does that mean W equals Y? Or does AX equals B have at least two, and therefore infinitely many solutions? And again, we already have a theorem that covers this. if AX equals B has at least one solution. That is, if it is consistent, then it has one solution if all the columns of A contain pivot positions and infinite solutions if not. And this question, remember, whether t is 1 to 1, is the same as asking, does AX equals B have at least two distinct solutions? So, theorem, a linear transformation from Rn to Rm is 1 to 1 if and only if the standard matrix of the linear transformation has a pivot position in every column. So take care not to get this theorem and the previous theorem confused. One is asking about pivot positions in columns. The other is asking about pivot positions in rows. In this video, we have seen how we can classify linear transformations as 1 to 1 and or onto by investigating the pivot positions of the standard matrix. In the next video, we'll do an example of this.